Hi, my name is Danilo and I'm Chief Evangelist for Amazon Web Services for Europe, Middle East and Africa. And today I'd like to cover a topic that is really interesting for me. It's how can I leverage the cloud to build event-driven architectures. So the agenda today is to start from APIs, that is the normal interface we use for microservices, and how we can start to mix or transition from APIs to events. And then we will give an example of how you can build event-driven architectures using using Amazon Event Bridge. And I'm using the term choreography here because often in IT there is this contraposition between choreography and orchestration, and we will see an example later. Now with choreography, normally you have each component of an architecture knows what to do, and then when they work all together, the final result is what you expect. And this is an example of an event-driven architecture. Its component knows which events it should receive and which events it should publish, and they can communicate and work in this way together. Orchestration is an example when you have an external system that is strictly coordinating the work of the components, and sometimes you need this approach too. And I will show how you can use orchestration together with event-driven architecture. In the middle of this session we will have a case study. And then at the end I will focus a little bit on observability, because with event-driven architecture it's really important to have a way to understand what is happening in this exchange of messages, of events, and also to be able to drill down in case that something not expected happens. So let's start with APIs. So when you build an architecture in the cloud, you normally have small components that are loosely coupled with each other. This is what you should do so that you can develop them independently, you can deploy them independently. And the API are really the front door, the standard way you communicate with other services. You publish your application programmable interface, and then other services know how they can send a message and what they should expect in return. And APIs are really contracts in this way. It's a contract between one service and the other services that define how they should exchange information. And the more stable these contracts are, the better is the development of and easier is the development of your architecture, because if you develop something inside a microservice, you know that you're not changing your API, so you're not affecting the work of other teams working on other microservices. So this independence created by an hardened contract is really important. And managing APIs is very common across our customers. That's why we have a service that can help you do so. It's the Amazon API Gateway. It can help you have public-facing APIs on the internet. It can be, for example, the backend of a mobile or web application. You can use this for publishing APIs that are consumed by other services. And you can also publish private APIs inside your VPC so that to communicate with other microservices of your internal IT department. For example, Realtor is one of our customers using the Amazon API Gateway. They have a real estate website, so processing images is really important for them, because when you search for a real estate property, you want to look quickly to lots of thumbnails, and then you want to drill down and get very high quality images for the properties you're interested to. For this reason, they decided to use the Amazon API Gateway to process 800 million of images every day and be able to serve their customer in an easy way. To make this even better, at the end of last year, we launched a new way to build APIs with the Amazon API Gateway. We call it the HTTP API. And it's lower in cost and also lower in latency, so it's faster for your users. We also simplify the way you manage authentication and also the way you manage, for example, courts if you're building a web app. And so it's really the way I would suggest you to go if you build a new API with the Amazon API Gateway. It's integrated with AWS SAM, and it still doesn't have all the features of the old REST APIs, but if you can fit into this model, it's much better. So when you start building a serverless application, you have these APIs, like in the example that I showed before, but you also have multiple services, and these services can be triggered by events, because it's the way, for example, tools like AWS Lambda work. So can we leverage this? Yes, for example, how do serverless applications work? more generally. So on one side, when you build a serverless application, you have these fully managed services like the Amazon API Gateway, like S3, Amazon S3 for storage, like DynamoDB for databases, and so on. But we never use the term serverless for just S3. No, S3 has been there for now more than 14 years. We start to use the term serverless when functions like AWS Lambda became available at the end of 2014, because functions can plug in your unique business logic. And how do these functions work together with the fully managed services? Via events. This is the way they communicate. No? So you receive an API call by the API gateway, and this triggers a Lambda function that will do something and return a value. You upload a file on S3, and this triggers a Lambda function that is processing this file. Maybe it's a document, it's extracting information. And then this function can work on other services. For example, it can write the result of the analysis of this file on S3 into a DynamoDB table, and this triggers another, creates another event that triggers another Lambda function. So you can chain together multiple services and multiple components, building an event-driven architecture. And when you build this function, you should focus really on creating business value by using a function. So this function should at least transform some data, should not just transport and move data around from one service to the other. If you see that you write a Lambda function just to move data, probably you can replace that with a service-to-service integration. For example, some customers use the API gateway directly connected to Amazon Kinesis with Kinesis firehose to store the data on S3 for further processing. Also, the management of errors and retries should be left to the service. So you should try to avoid to put this inside your business logic, because this is the kind of things that make application complex without adding value. They are very important, but they're not part of your business logic. They shouldn't. And also try to minimize the invocation, so read only what you need. So try to filter data. If you use SNS, we will see how you can create very complex rules with Event Bridge, and from X3 try to receive only invocations events if specific, for example, prefix is invoked, and so on. And also, when you call a Lambda function, you can call it synchronously and wait for the result. That's what the API gateway does, or asynchronously. So you launch a Lambda function and the Lambda function does its processing. This is the way, for example, S3 works. S3, you upload a file. If this triggers a Lambda function, the Lambda function is invoked, but S3 is not interested in the result. It's just starting this processing. We will come back to this asynchronous thing to see how we improve there. So how can we build something event-driven using Amazon Event Bridge? Let's start from what we mean by event-driven and even by event. So an event means that something happens. This is what the dictionary tells us. And it's a fact, no? A file has been uploaded, an API call has been received, maybe a new customer has been created on a database. And they are also immutable facts, no? Because if something happens in the past, you cannot change. You can maybe delete a customer after some time, you can delete a file on S3 after some time, but this is another event. You're not changing an event in the past. So they form an immutable time series, and this is good because anything that is immutable, it's much easier to process in a distributed architecture, because if you receive an immutable fact, you know that it's true. If you receive a value that can be updated continuously, in a distributed architecture, it's very difficult to know if the value you got is updated or not. So working with events helps also in this way. And in a way, events change the way you communicate information. With APIs, you are sending commands like create an account, add a product. So each API call is a command with an intent. It's directed normally to a specific target. It's like personal communication. I'm talking to you directly. With events, you're telling a fact, as I said before, and it's for others to decide what to do with this fact. It's a broadcast, something that you broadcast to everybody who can be interested to. So if a new service pops up and it's interested in your event, it can subscribe and receive the event. You don't have this one-to-one communication as with commands. And you're not thinking about giving commands, you're really telling facts. So it's not that you tell create an account, but the system that creates an account at some point says, hey, this account has been created, who is interested in this information can process the result of this. To simplify this kind of asynchronous event invocation, we introduced the Lambda event destination. And this is a way to process the result of an asynchronous invocation for Lambda functions in case of success or failure. You can really tailor what you want to do. So, for example, if you receive an invocation from S3 to process a file, you do this processing. If you get the result of this file, in case of success, you can pass this to another Lambda function or to Amazon Event Bridge. In case of error, maybe you want to store this into an SQS queue for further processing. So you can choose what to do in case of success or in case of error. My suggestion is, in case of success, use Lambda to Lambda direct integration inside a microservice where you have multiple functions, because you have tight control there. But if you have to communicate with another microservice, then it's better to go through Event Bridge or SNS, but I will show you that probably Event Bridge is the easiest way to go for this kind of service-to-service integration. So just a quick look at how you can use this. So this is the this Lambda destination. This is the console for AWS Lambda. So if you click here, you can add a destination. I'm talking here of the asynchronous invocations. The stream invocation is for streams like DynamoDB streams or Kinesis data streams. And then you can choose here, in case of failure, I want to send this to an SNS topic or an SQS queue. In case of success, I want to pass this to another Lambda function or to an Event Bridge bus, and then you can choose which bus you want to use. And this kind of configuration is also easy to set up in a SAM template. With a SAM is a way to describe your serverless architecture in a template file, and you can set up the event invoke configuration, and when you can set up the destination for success or for failure with this syntax. So when you start to use this event-driven communication in asynchronous invocation, you can really start to build something more sophisticated. So on one side, you have your client, for example, your mobile apps, your IoT devices that send events directly through an API or through a stream, like using Kinesis streams. And then this goes to Lambda functions to be processed. You will see when you can use step functions to orchestrate multiple services together, and you can use other messaging tools. Normally there are three main ways to exchange messages between applications. On one side you have Amazon SQS, it's message queuing. So message queuing is when you have a producer and a consumer that you want to decouple, so that the producer can produce information, send it into the queue, and then the consumer can pick up the information and process it at its own pace. This is very common also in our internal AWS and Amazon architecture, because sometimes you have different processing speeds between two services, and having this decoupling helps. And maybe you want to just stop a service for some time to do some debugging, and the queue can help you store the data until you reopen the processing again. With PubSub architecture, like with SNS, you normally create topics, and each component can subscribe to a topic. So this is a kind of event-driven architecture. The complexity here with tools like SNS is that at some point you can create lots and lots of topics. You can use message filters, but this is on attributes, so it's not really flexible as much as you want. So you start to have lots of topics, and then you have to decide which topic you want to subscribe on your service. It can be complex at scale. With Event Bridge, you have an event bus, so you have fine control, creating rules on what kind of information you want to receive and from different sources. So this is the overall architecture of Event Bridge. So you can receive events from AWS services, so maybe autoscaling is starting or terminating an instance and you want to be notified. You can create custom events like the one that I showed before, like I created a new customer, I created configure a new product in the catalog, and so on. And you can also easily integrate with Event Bridge with external services, software as a service platforms like PagerDuty or Zendesk. This event go to one or more event bus. Normally you want to separate event bus. You don't want to have a lot of event buses, but you want to have an event bus maybe for a specific topic, not say topic, let's say for a specific set of applications. So maybe IT operations is using the AWS default bus to be notified by AWS events, and maybe your internal applications, CRM, billing, contact center, they use another event bus where customer information is exchanged. And then these rules can process this event and decide to route this event to a Lambda function, to a Kinesis stream, to step functions, to that's a lot of targets that are supported by this integration. This is an example of an event that you can get with Event Bridge. And this is, for example, a ticket that's been created by a specific source and with this information in the detail. And then you can create a rule that says, for example, I want to receive anything that comes from this list of sources. There is only a source here. There is a match, so this event would be routed by this rule to a target, for example, a Lambda function. Or you can enter into the detail and say, I want to be to route only events if they are coming from the billing or fulfillment department. So in this case, again, you have a match with the billing department, so this will work. Or you can enter into the detail type. The detail type normally tells you what's the kind of information inside this event. In this case, I want to be notified only if the ticket has been resolved. This is a ticket created, so there is no match and no routing. And there are lots of common use cases. So you can use this with SaaS application or other internal services in your architecture. So you can take action if something happens, of course, with a Lambda function that can customize. For example, there is some event coming from PagerDuty, and then I want to react and automate some kind of reconfiguration. You can start a workflow, and I will dive deeper into that in a moment. Or you can apply machine learning intelligence. So maybe you receive the updates to a trouble ticket with the comments, and you can use tools like Amazon Comprehend or a custom machine learning model with SageMaker to analyze this text and get the sentiment and understand if the ticket is going in the right direction. You can store everything on S3 using, for example, Kinesis data firewalls, and then analyze and audit what is happening with a tool like Athena. With Amazon Athena, you can run SQL queries on your S3 files and create reports, for example. Or you can synchronize data, so you can use a Lambda function to receive an event, fetch additional data, and then update a DynamoDB table or another database so that you have something inside your architecture synchronized with an external service. We are really working to expand the number of integrations that you can use. So we have a program where external partners can integrate their SaaS products, and there are lots of them, from Zendesk to MongoDB to Auth0, for example. And you can use this also to integrate an event-driven architecture, not just to receive events from a front-end client, but from another service. So you can really integrate with different layers on an application, from the presentation, from the logic, from the data layer. When there is an update on a database, you can process these events. So it's really flexible and can really help you build an architecture that it's not just 2 layers event-driven, where you receive event and you process them, but can have multiple layers. And we also work to simplify the way you process this data. When you have external provider or you receive events from AWS, you want to have a schema registry that tells you what is the expected format for an event. And also to automatically discover the syntax of events that come from a new source. So this is something that we integrated with the Amazon Event Bridge. So let's go quickly on the Event Bridge console, just to have an overview. So here you can configure your event buses. Here in this region, I only have the default event bus from AWS, for example. And then you can create your own custom event buses for your application. Here you can create rules, and creating a rule is really interesting, because when you create a rule, you can say, I want to schedule something that is executed periodical, or I want to create a pattern. And this pattern, similarly to the example that I shown before, can match a specific event that is coming from a service pattern, or can come from an AWS source. Then you have AWS services, and then you can define which event path this rule should work, and then you can define the targets. And as you see, there's lots of targets. So with Lambda function, SNS, SQS, Kinesis are probably the most common integrations. The syntax you would use is a syntax where you can send the all events that match. You can send only a subset of an event using JSON path. All events are in JSON format. You can send a constant JSON message as the result of the match, or you can use also a transformer to enter more into the format of the message. This is an example of the integration between MongoDB Atlas and EventBridge using MongoDB Stitch. So here you configure an integration with a specific collection on a MongoDB that is managed by MongoDB Atlas. And you say, I want to connect this with this account and this in this AWS region. And then Amazon EventBridge will automatically discover the schema for you. The schema will depend on the fields, the attributes that you use in the MongoDB collection. And then once it's there, you can use it anywhere. So for example, in the we have toolkits for multiple IDEs, and this is an example in Java. Being Java strongly typed, it really helps to be able to inspect the format that you should expect from this event. And also automatically when you're coding and in your project, you can just autocomplete the object that you receive from the event bus with the expected attributes. So in this case, we can automatically look into the document that we receive. It's part of the detail that we receive, and then for the document we have the multiple attributes that are in my MongoDB collection. So it's really custom to you. Let's see a quick case study. So one of the customers that I really love also for their products is Lego. And they switched their e-commerce platform completely on AWS last year in July. And the day after they did so, we launched EventBridge. So this created some thought for them to say, this can help us simplify even further. And what they were thinking was their checkout. So the checkout of the store is normally a part of an e-commerce application where you need to exchange information between multiple components. You have to manage the order, you have to check the payment, you have to do the checkout processing, you have to start and control and update the shipping. There is the login. You need to synchronize this information with maybe the part where you manage your very important customers. And normally you would do so with lots of point-to-point integration on using SNS. You would have lots of topics. They wanted to create a clear architecture based on a hub and spoke event bus, where everybody's sending and receiving information from the same event bus, and then you can create the rules to do so. So they start transitioning. As far as I know, this is still ongoing, but they replaced lots and lots of SNS topics with a single event bus with EventBridge that is receiving events from the commerce platform, is processing this information and can coordinating with payment, checkout process, the order management, and the shipping of the product when the order is completed. So it's really much easier for them to have a central point with all the rules compared to have lots and lots of SNS topics. And this is probably a suggestion for you. So if you start to see that you're using SNS and you have lots and lots of topics, this is a good indication that probably EventBridge can help you simplify this setup. This is the syntax of the event that Lego is using. So normally, this is the standard syntax of EventBridge, and you have the detail where each customer can put whatever information they want. They had this interesting idea to split this detail in two parts. One part that they call the metadata is standard across all their microservices. And then they have a data part that is custom for each service. In this way, when they create the routing information, they know that each service is sending the metadata with these fields. So they have a type, a subtype, for example. And then when they process each target receives the event, then they can enter into the data and then can enter into the specific information of an event. Sometimes event-driven architectures can be not the easiest way to implement a solution. I'm thinking, for example, of what in the past you would do with the distributed transaction. So if you have multiple microservices that needs to be updated at once, doing so with event-driven architecture can be complex and error-prone. That's an example where you need orchestration. You need something like AWS step function that can coordinate the work of multiple components together. And normally, when you do so, you have you want to design what is a business workflow, and this can help you track the status of a business workflow because it's not inside your code, but you have smaller components, and the workflow tells in which component you are at each step. And it will remove lots of redundant code that is not part of your business logic, but you have to put there to manage the interactions. So this is moved into the service that is managing the orchestration. And business workflow really normally benefit from that because they're normally not sequential. So you normally don't have just a list of action, but you have multiple events, multiple tasks that can be processed at once, for example, and you can have a branch that manage errors depending on where they happen. So it's much easier to visualize something in a diagram like this compared to put everything inside a single code base. And step functions started with Lambda and works very well with Lambda. So we have this example, for example, of processing images. And what you do is you receive an image, you extract the metadata, check that the image is correct. And then if the image is in a format that you can process, you can in parallel build the thumbnails of the image and also use a service like Amazon Recognition to analyze the image and extract information on what is inside the image, for example, and then store this information on a metadata repository like a DynamoDB table. So having these multiple tasks with choice, error management, and parallel branch, it's very complex to do in code, and step function can really help you. And now step function is also integrated natively with multiple services. So you can use it natively with SNS, SQS, with machine learning platform like SageMaker. You can use it with Glue to coordinate your ETL layer when you store data, for example, in an S3 data lake, to launch batch jobs with AWS Batch, to manage container tasks using ECS and Fargate, and more recently also with EMR, so if to coordinate the multiple steps of your analytics. And when I talk about this direct service integration, they really simplify the workflow. So, for example, if you launch a job on a AWS Batch, without a direct integration, you would have to write a Lambda function that periodically polls the job to see if it has completed and then checks the result to see if it's an error or is a successful completion. With a direct service integration, you just say, hey, send this job, and when this job is completed, send me the result of the error, and then I move on to the next step. So that the business workflow is much easier to visualize. Normally, step function can be used for medium to long living workflows up to 1 year. But if you have something short living and high volume, we launched recently the Express workflows. There is a way to use similar functionality, the same functionality as the step functions provide, with some very small changes for asynchronous jobs and activities, but anything else is there. And in this way, you can manage high volumes. It's also more cost effective at scale and can be used for scenarios where you have lots of invocations. So if you have a very large, I would say a fat Lambda function, decompose it into an Express workflow can be an efficient way to optimize your source code and build a code that is easier to develop in the future. Step function has also been integrated in the AWS toolkit for Visual Studio Code. So if you use this toolkit, you can visualize graphically what's the result of a JSON step function, state machine definition. Final part today is on observability. This is really important because when you have an event-driven architecture, you want to be able to understand if everything is working as expected at service level, and if there's something that is not going as you want to be able to drill down. So In this case, we provide a service to help you do so. It's AWS X-Ray. And X-Ray is something that it's integrated with Lambda and the Amazon API Gateway and other services like AppSync or SQS. And if you integrate it with, if you enable it with Lambda and API Gateway, you already have a trace. You can build something like this. This is a service map that tells you all the invocation across a distributed architecture going across multiple Lambda functions, DynamoDB tables, for example, API Gateway endpoints, what is the flow that you're having and where you're spending your time if you're getting errors in some places. This is useful, but if you want to get insights in what is happening inside a Lambda function that maybe is calling other services, you need to use the X-Ray SDK, like in this example here. Normally, this is an example in JavaScript, not JS, but it's the same in all platforms. You need to take the X-Ray SDK with you, and then you need to wrap the AWS standard SDK that you use to call S3 or DynamoDB, for example, with X-Ray. Once it's wrapped, you don't need to change anything in your code, but anytime you're calling an AWS services like S3 or DynamoDB, they will be traced. Tracing works normally on a sample, especially at high volumes. You want to trace maybe at 3%, 5%, 1% of your invocations. You don't need to trace everything. It would just slow down. And then on each trace, you can drill down. And more recently, we added the possibility to have a trace map. So on each trace, this is not an overall average of multiple invocation, but it is a single invocation that is going across multiple components. You can have a map of what is happening, and then you can see in the lower part where you're spending time and what's the flow of your request. Maybe you're moving from a Lambda function to S3, then you're calling a DynamoDB table, then you're sending back a result. One feedback that lots of customers gave us is that with X-Ray you have this vision of the architecture and the flow of your application, but they want to connect this to other information that they already have on AWS, maybe their logs on CloudWatch, their metrics on CloudWatch. That's why we launched CloudWatch Service Lens. So Service Lens is it provides you a graphical user interface that is similar to X-Ray, is based on the data that is collected by X-Ray, so you don't need to do anything else to use it. But if you click and select a Lambda function, you can see the metrics and go straight to the logs of that function to understand what is happening. If you click on a DynamoDB table, you see the metrics of this DynamoDB table. So it really helps you drill down into each component and get all the information that we have on CloudWatch and correlate that with the information from X-Ray. I've seen that normally customers want to get metrics not just for technical events like what's the latency of my Lambda function, but also their own business custom metrics. So for example, I have a serverless application that is doing e-commerce. I want to know how many sales per minute I'm doing, how many search in the product catalog any minute there are. In this case, if there is a problem in my application that is affecting these business metrics, I can get an immediate feedback that something is going wrong. Maybe if I look at the latency of my functions, I don't understand that something is not working. Creating this kind of custom metrics with ephemeral resources like functions or containers that you create and maybe in auto-scaling and destroy has always been complex. That's why we launched the new CloudWatch embedded metric format at the end of last year. And we have a library for a module for Node.js and also for Python. But actually what we're doing is we're writing a log on CloudWatch logs with a specific JSON syntax. And if we find in your log, CloudWatch logs, this JSON syntax, we will automatically extract the information and create a matrix for you. So this is really something very easy to use in any language if you know the syntax, or with Node.js and Python using our libraries. And my suggestion is always find the 1, 2, 3 top business custom metrics that tell if your application is working, and in this way you can correlate this with the technical metrics that you get, latency, speed, and whatever. It's really important and can help you also roll back when you make a wrong deployment faster. So what now? We've seen multiple approach to event-driven architecture. You can also, with an event, trigger a smaller orchestration using step functions. You can observe what is happening with tools like X-Ray and CloudWatch Service Lens. How can you find your own success with this approach? So we've seen that normally most customers go through 3 stages. They start with using event-driven and serverless for IT automation, so internal tools that needs to run periodically, needs to react to something happening in the infrastructure. This is a very good way to get practice. Normally you stay within the free tier, so there is really no cost in doing so. And then from this they move into something more advanced like data transformation, and then they move into more business critical application. Serverless really can help you develop faster, add new functionality, reduce time to market, especially if you want to build a new prototype. And normally what I've seen with customers is that it's not just a technical thing for developer, it's really giving you an advantage that is visible at business level. So you should really focus, especially on the cloud, on getting business agility, building architecture that are elastic, that can adjust up and down depending on the actual workload. And in this way, you can normally drive down your cost and be very efficient. There are online trainings that can help you learn more. There's a link here in our training portal that can help you build modern applications on AWS, not just serverless, but using modern components like serverless containers like with Fargate. And also have a look at the AWS well-architected framework. That is a way we are sharing our best practices. There's also a well-architected tool that is free to use where you can benchmark your applications with our guidelines. And now, since a couple of months, also the Serverless Lens that is focused on serverless components is available there. So you can really get questions focused on your serverless application. You tell us how you're doing, and we can help you understand if there are risks in what you're doing and what are the possible mitigations. It's a free tool that you can use. It's really something I would suggest you have a look at. There's more tooling available. I was talking about the AWS stuff, but our partners are creating a lot of tools that can help you in the development, like with Serverless Framework or Terraform, or in the observability and management of your application. And also there are some partners here today. You can visit them in the partner discovery zone, meet them, and they can really help you understand how to move your application to the next level. Thank you.